Okay, so we're going to go through these problems here. We're going to do a percent composition first. And we have a student here that's going to help me through these problems as practice for our exam tonight. So let's see what we got. What is the first step in this percent composition? Good. So how do we do that? We start with the 50 grams. Good. So what is that going to be? Have you already done that? So, so that means 88.02 grams of Na2CO3 for every 1 mole of Na2CO3. Good. And when you multiplied that out, what did you get? Now what? Okay. Okay. So you're saying because of the subscript here, okay, so what we should do then technically, ooh, that was too big an eraser. Let's get that back down. Is we should say 2 moles of Na for every 1 mole of Na2CO3. Okay. So now what? What happens when you multiply those? Okay, equals 1.13 moles of Na. How does that help me? Okay, how can I get the grams of Na? That's okay, I'll edit it out for you. But we learn from our mistakes, okay? So don't be afraid to make mistakes. You caught it, right? I didn't have to correct you, you corrected yourself. So we know a way to avoid making that mistake is by doing this conversion factor. We know that the molar mass is the conversion factor to get us the from moles to grams. Now let's look at our periodic table to see what the mass of sodium is. And it's 22.99 grams. So at this point, when you multiply it, what did you get? Okay. Okay. So what do we do? Are we done? Okay. Now what? And what do you get? Good girl. Now what? Okay. Um, now, okay. Good. Good. Now, had I asked for each element, what would you do different? If I wanted CO3, the easiest way to do it would be to take that 100% minus 51.95, which is going to give you 48.05%. Okay, but what if I wanted carbon and I wanted oxygen individually? Could you do that? No, because it's not the same element. It's not the same element. But you could do it the same. Can't you do it the same exact way you did sodium? All right. You could do a mole ratio, and for 1 mole of Na2CO3, there would be 1 mole of carbon, and then for 1 mole of Na2CO3, it'd be 3 moles for the oxygen. Do you see it? Or do we need to do it? Okay. Uh, I I think this next problem is a little bit more important. Do you have all this written down?